Rita!
Can we just go over the notations for like the answer for number 43, like how to write it that way?
Sure. Shh. Okay. So like 33 says, for what values of x does the graph of f have a horizontal tangent? So what we want to do is we want to find where does f prime of x equal 0. Okay, so we'll start by just calculating f prime. So the derivative of x is just 1. The derivative of 2 sine x is going to be 2 cosine x. So when we set that equal to 0, we can solve and we see cosine of x is equal to negative 1/2. That happens when x is what? 2 pi over 3 and 4 pi over 3 on the unit circle. So I would write that as 2 pi over 3 plus 2 pi k, or 4 pi over 3 plus 2 pi k, again, where k is an integer. Now, I think the back of the book had some other notation. It's equivalent to what this is saying. You can say it, absolutely could say it like that. I don't, when I looked at it, what the notation the back of the book gave, I haven't ever seen anybody use that notation before for a problem like this, but like, I think it was simply to make it take less space, like it was fewer keystrokes, which is fine. But yeah, it's equivalent to this, and this is how I would have expected you to answer.
Yeah, this makes a lot of sense.
Carmen?
Where did you get the 1 plus 2 cosine x?
So I did the derivative. So the derivative of x is 1, and then the derivative of 2 sine x is 2 cosine x.
Oh, we're doing 33. I thought we were doing 34.
Oh, yep, nope, 33. Yep, that's okay. That is okay. I mean, sure. So again, if we're doing the derivative, how do I do the derivative? What do I need to do the derivative of e to the x cosine x? That is a product rule. Yes, very good. So we have f times g prime plus g times f prime. So I would write this as e to the x cosine x minus sine x is the way I would write it. And we'll set that equal to 0. So e to the x equals 0. Well, that has no solution. If I do the natural log of both sides, the natural log of 0 is undefined. So nothing comes from that. But when I set cosine x minus sine x equal to 0, that I can solve. Trigonometry refresher. How do I solve this? I'm going to add sine to both sides. And then I'm going to divide both sides by cosine.
Oh, so tan?
Yeah, exactly right. And where is tangent equal to 1? That's at pi over 4. And at 3 pi over 4. But remember, the fundamental period for tangent is just pi, so I don't really need that one. I meant 5 pi, not 3 pi. And just do plus pi k at the end of that. Or k is just some integer. Oops. right? Pierce.
How'd you divide cosine over again?
Well, cosine divided by cosine is 1. Sine divided by cosine is tangent. Does that feel okay?
Yeah.
Elena, you happy with that for 34?
Yeah, then why is that too high?
Yeah, so if I remember, the fundamental period for tangent is just pi, not 2 pi. So I noticed that you could write that, and that's fine. Or you could just nix this one and take off the 2, and it's the same statement. It's okay to write, pi over 4 plus 2 pi k, and then 5 pi over 4 plus 2 pi k. Totally fine. Equivalent answers. We're just striving for compactness. Braden. Sure. 55. This one's just like a bugger, isn't it? Let's see. What does this one look like? Okay. The figure shows a circular arc of length S and a chord of length D, both subtended by a central angle theta. Find the limit as 0, or a theta approaches 0 from the right, of S over D. Now, intuitively, what should this be? If that angle's getting smaller and smaller and smaller, what's the ratio of S to D going to be getting closer and closer to?
1.
They're going to be closer and closer to the same measurement, right? The smaller that angle is, right? Like if we only have like that much of it, D and S are almost the same thing now, right? The smaller that angle gets, the closer those look like to be just the same measurement. So that's the intuition. Now, how do I do this with a limit? What do we think here? I have my idea, but let's see what the textbook does before I go and use something more than I want to. When I see this to me looks like a good candidate for a squeeze theorem. But let's take a look here. That's easier than what I would have done. Let's do that then. All right. Back to trigonometry. What's our arc length formula? Good. So we have that. And if we draw in this, we know that that line that I've drawn in bisects the side D, and it bisects the angle theta. Why can I say that? Not because it's a chord. What kind of triangle is this? No, it's not. It's isosceles, yes. So that property that I just stated is true for all isosceles triangles. That if you take an angle bisector of the apex, that's also going to be a perpendicular bisector of the base. Everybody's okay with that? So if I use that, if we draw that right triangle in, that's going to be the right triangle who's with angle theta over 2, hypotenuse r, and side d over 2. So sine is opposite over hypotenuse. Oh, thank you. Everybody's okay there? Okay. So what I'm going to do now is I'm going to get the d by itself. So I'll multiply r to both sides. And then I'll multiply the 2 to both sides. Good with that. So I now have S that I know is r theta, and I know d, which I know is 2r sine theta over 2. So let's go ahead and plug that all together then. So I have, what was it? It was S over R, right? Yeah. So I have R theta over 2R sine theta over 2. So what do you notice straight away? The r's can cancel, right? Let's do that. Get rid of that. And what I'm going to be looking for using, once I've made these substitutions, is if I go back and look at 3, I want this guy right here. Right? That's starting to look like kind of what we have. Everybody's cool with that? And obviously, if this is equal to 1, if I do theta over sine theta, that should be 1 also, right?
Oh.
Which is kind of more what we have. Everybody's okay? So I'm still going to be using that. All right. So I'm going to pull that 2 out front from the denominator. And instead of thinking about theta, I need that to be theta over 2. So let's do that. Those will cancel. And now this is just 1. Everybody's okay there? That was going to probably be much less than trying to cook up a squeeze theorem. Although I suspect you could still do that using like a some trigonometry there. I think it would have gotten much worse than what we just did there, which was took a little bit of geometry, a little bit of trigonometry recall, but I think just thinking about the problem, though, was what I really wanted you to get out of this, is be like, okay, if this angle is shrinking, those two measurements are basically going to turn into the same, right? Once that's infinitely small sliver, that's all I really wanted. The reason I assigned that was to get you thinking about it like a calculus student. That like, okay, that essentially if the slice is thin enough, that arc is just a straight line. Becomes an important idea later on. Okay with that? Okay. Elena? Sure. Okay. So if h of theta is equal to theta times sine, find the first and second derivatives. So what do I need to do to differentiate h of theta? Product rule. So I have f times g prime of x plus g of x times f prime of x. And then the second derivative is going to just be the derivative of the first. So again, to do theta cosine theta is another product rule. Yes.
That's just times 1?
Yeah.
Okay.
So doing the same thing. And then the derivative of sine is just cosine. So I think I have 2 cosine thetas minus a theta sine theta. How's that feel, Lena? The second part of this course is as you get more comfortable with the operations, it's like what you want to start thinking about is like, what's the easiest way to do this? Because oftentimes it's not difficult to do it once you see the easy way to do it, right? Again, most of the time your problems shouldn't run like a whole sheet of paper. That's an unusual situation for most of these kinds of problems. Unless they're like really mean. And sometimes they can be really mean. But something like that looks as innocent as this to start with, I would not expect to, even if I'm asking for a second derivative, to look too bonkers. Okay. You guys ready to chain on? Yes. All right. Chain rule for today. This is of the rules that we're talking about in here, chapter 3, which is all these just derivative shortcuts. This one tends to be the hardest one for students to see that, hey, I have to use this, or how many times I might have to use this in the same problem. Essentially, what this problem is saying is to do the derivative of a composition. You do the derivative of the outside times the derivative of the inside. That's really what this is saying here. F prime of g of x is the derivative of the outside. Leave the inside alone. Times g prime of x, that's the derivative of the inside. Okay. When I talk about doing the chain rule, that's the verbiage I like to use. That's the way that I look for situations where I'm going to have a chain rule, is thinking about, okay, what's the inner and outer function or functions? Yeah. It's saying the exact same thing, whatever you're more comfortable with. This comes up when we talk about implicit differentiation. We tend to use that notation. But now, if you remember, in trigonometry or pre-calculus last year, there's some homework problems where we asked you to like think about something like this as some composition and to state like what was the F and what is G. So if I look at something like this, what is f in this case? The square root of x. And what's g? The x squared plus 1. F is the outer function. G is the inner function. Now, Mr. Kulik, why didn't you pick like f of x to be the square root of x plus 1 and g of x to be x squared? Right? That's a possibility. Why didn't you write it that way? Very important answer to that. I know how to take the derivative of both the square root of x and the x squared plus 1 with the derivative rules I currently own. I don't know how to do the square root of x plus 1 using the derivative rules I currently own. That's why the square root of x needs to be my outer function choice for f, and x squared plus 1 has to be the inner function choice, my g of x. Everybody's okay there? So what's the derivative of the square root of x? Good. And what's g prime of x? 2x. Okay. So f prime, capital F prime, should be f prime of g of x times g prime of x, right? So I'm going to be taking my g and plugging it into the x in f prime. That'll give me f prime of g of x, right? Like a function composition. And then times g of x, or g prime of x. Now, the answer in your back of the book is probably not going to look like this. They will certainly simplify this. So they'll do that. And I would expect that they would write this without the negative exponent and putting the radical back in, considering the problem had a radical to start with. In general, whether it's on the AP exam or in a textbook or whatever, the form that your starting problem is in will probably be the same form that your answer should be expected to be left in. So if you had fractional exponents in your start, your final answer probably should have fractional exponents in it. If you had a radical when you started, your final answer is probably expected to have a radical in it. Everybody's okay with that idea? Okay. All right. Let's do another example. Yes. Yes. And the wrong answer would be if you can't do the derivative of either your f or your g.
If you know how to do it, can they like flip flop or like does it really matter their order?
Yes, the order matters because I know that, for example, Elena, that f of g of x does not necessarily equal g of f of x, right? That was a property of function composition that we talked about in trig and pre-calc.
How do you know what's your side?
Why, in the case of this, the thing that's inside the square root is the inner part, right? That's the outside. Because if I'm plugging that in, right, if I do f of g of x, I'm taking my g and plugging it into the x in f of x, right? Right, if I do f of x squared plus 1, I'm plugging x squared plus 1 into the x in square root of x, right? Just like when we did compositions in Algebra 2 and in pre-calc and algebra and trig, like all that. Does that feel a little better?
Yes.
Okay. Yeah. Good. Again, this takes maybe a minute to kind of get comfortable doing, like seeing the inner and the outer. And in cases where you have maybe like 2 or 3 or 4 chains in the same problem, can get kind of difficult. And we will see that eventually. All right, let's look at this next one. So for part A, we have y equals sine of x squared. What is my outer function going to be?
Sine x.
Good. And the inner function?
X squared.
Good. So the derivative of sine is? Good. And the derivative of x squared is?
2x.
Okay. So my answer then should be f prime of g of x times g prime of x. And again, we would probably write it where the 2x is like a coefficient, but whatever. Everybody's okay there? So notice here, like I took the derivative of that part, the outer, but the inside stayed the same. And then I have times the derivative of the inside, right? It's just the derivative of the outside times the derivative of the inside. Okay, so the next one is y equals sine squared of x. How is this different than y equals sine of x squared? Yeah, sine squared of x is really means this, right? We just don't write the brackets and we just put the squared on the sign for, well, really saving us keystrokes, right? Like it just keeps everything from getting too messy. So what is the outer function in that case? What? X squared. Great. That's perfect. And the inner then is sine x. So the derivative of x squared is 2x, and the derivative of sine is cosine x. So my y prime then is f prime of g of x times g prime of x. Right? So I've taken my g and plugged it into the x for f prime. That's that part. And then I have times the g prime. And if you're really sneaky, what else might you write 2 sine x cosine x as? That's a double angle identity that you might have remembered from trigonometry. Or not. No one's expecting you to remember your double angles. But if you're going to be an engineer, that's a plan. Remembering those things is often quite helpful. Yes?
Why was that outer function x squared?
Because if I look, the x squared is being applied to The squared is being applied to the sign, right? So the outer function is the squaring, and we just need one spot to plug something in, so it's just an x squared. Does that?
Yeah, that makes sense.
Okay. Elena.
You have like a coefficient on the side. I wouldn't know if it would be x squared, like for that on the outside.
So you have, this is a hypothetical. So Elena says, if I had this, that's what it would mean. So our y prime would just be 3, and then our answer from before.
Oh, so you can, you know.
Yeah, we can treat it just like a coefficient, just like we do for all of our other derivatives.
Okay.
Does that feel good?
Yeah.
That's what you wanted, right?
Yeah.
Was an example like that?
Yeah.
Okay. Okay, keep on going. Now, this rule here, what is this saying?
Not sure.
This is just the chain rule applied specifically when the outer function is a power property. Like this most recent problem we just did, right? Where your f of x is some power property derivative. That's all this is saying. So do you need this? No, it's just a special case of the chain rule as we've already discussed. That's all that is. It's just a special case of the chain rule that we've already discussed. Do you need to memorize this? No, I would not bother with it. I would just worry about the chain rule. Okay? I wouldn't worry about this as a memorizer. Okay? We good? Does you appreciate me kind of as we're walking through what is this really saying? Yeah, we're not proving in it. I give up on that. Okay. What's the derivative of y cubed minus 1 to the 100? Should I FOIL that all out?
No.
Definitely not. I'm not doing it. What are you guys crazy? No, I'm going to think about this as a chain rule problem. What's the outer function? Excellent. And the inner? Great. So the derivative of the outer is? Great. And the derivative of the inner is? Excellent. So my answer should be f prime of g of x times g prime of x. We'd probably write it as 300x squared. What do you guys think? Heck of a lot easier than foiling that out, right? Could you have foiled it out, though? Well, I mean, in theory, could one have foiled this? I mean, not you specifically, but someone, if you're willing, could have foiled that out. But why? But why? You wouldn't, right? Everybody's okay? All right. Let's look at this next one. F of x equals 1 over the cubed root of x squared plus x plus 1. If you look at this at first, you might think quotient rule and a chain rule inside of it when you have to differentiate the g of x, right? I don't want to think about it that way. I would want to think about this as one chain rule instead of doing a quotient and a chain. That seems like a better option to you guys, right?
Yeah.
How am I going to do that? Right? Is that the same thing?
Yes.
So the 1/3 is because it's a cube root, and the negative is because it's in the denominator.
I thought it was over 2x first and now 1/3.
Oh yeah, that's supposed to be a 3.
No, you're doing
I don't know, that's as messy as neat as I can apparently write a 3 today. But that seems like a much easier option, right? So again, this is part of what the skill that we need to develop is being able to see the easiest way to do something, right? Like, there's nothing wrong with doing it as a quotient and a chain. It's just going to be yucky. I prefer my life not to be yucky. All right. So the outer is? Excellent. And the inner? Well, you gave me the derivative, but that's okay. Let's write that down. Elena, you okay?
Oh, yeah.
Okay, we're talking through it. I just want to make sure. Okay.
Yeah.
And then derivative of g is? Good. So my derivative should be negative 1/3, and then my inner to the negative 4/3 times my outer. Uh, 1/3 minus 1 is 4/3, or negative 4/3, excuse me. Negative 1/3 minus 1 is negative 4/3. That's okay. Again, if you're not sure, like, say something if you think I've made a mistake. If I have, great. I appreciate you catching it. If it's okay, it's good that we talk through it to make sure that we're all on the same page, because you're probably not the only one that's questioning, like, is that arithmetic right? It's good to talk it through. Probably wouldn't write our final answer this way. So I'd put like a negative probably something like that. Oops, and then the 3. Yep, thanks, Braden. Or if you wanted to, you could push the negative sign through the numerator and make it negative 2x minus 1. That would be fine. Probably in a multiple choice setting, they wouldn't do that. But it wouldn't be wrong if you did. If this is a free response question, though, where should you stop? If it's a free response question, don't simplify. Because the AP grader isn't going to give you any more marks for simplifying it correctly. But if you simplify it wrong, they will mark it wrong. So if it's a free response question, you're done when the calculus is done. Don't simplify. Unless it says, like, specifically show this is equal to this, which they probably won't do. But unless the directions are really specific and, like, need you to simplify it, don't simplify anything. Just be done when the calculus is done. Okay? Again, as we kind of talk through, I'll kind of keep reminding us of those sorts of things. This one, what do we see? And inside of that chain is a quotient rule. Is there any sneaky algebra nonsense Mr. Kulik can pull to get away with not having to do both of those?
Yes.
So here's the option. We can do a quotient inside of a chain, which is what I would do. There's not another good option. Or you could turn this into 2 chains and a product.
Like quotient and chain's easier.
It probably is, but if you've forgotten the quotient rule, the product rule, almost nobody screws up unless they don't use it when they need to. But like the formula for it, almost no one screws up. So if you wanted to, and you were doubting whether you remembered the quotient rule, you could think about it that way. And now that's a product rule of two chains, and that would be fine to think about it that way. I would not, because I remember the quotient rule. But if you're like got on the test and you're like, oh no, is it f times g prime minus g times f prime, or is it g times f prime like if you're sitting there doubting yourself which one is which, you could do it that way and it would be fine. You'll get the same answer. Be more simplification, but that's okay. So far so good? All right. So this is, we named this thing G apparently, which is swell. So I'm going to call the outer H and the inner K. It doesn't really matter, but I don't like to, like mix my variable names if I don't have to. No, it would depend. So like Elaine, if you had the quotient should come first, because I don't need to do the chain until I do the derivative of the numerator, right? So the first thing that I encounter is the quotient part. So I do the quotient rule, and when it comes time to differentiate the numerator, then I need to apply the chain rule. Here, before I can do anything, I have to do the chain rule. If we did this, the product rule would come first, right? I have to do the product before I can start taking the derivatives of either piece. Does that make sense?
Yes.
And that's one of the hardest things to get straight when we first start doing this. It's like, okay, I see that this is going to have a chain and a quotient. When do I do which one? When am I encountering the chain and when am I encountering the quotient? Usually if you do this kind of thing, where you write down the inner and outer parts, helps, right? Because in the previous one, there is no immediate inner and outer until you do the derivative, need to do the derivative of the numerator. Okay. Derivative of h is? Okay. Quotient rule. It's the two. Yep. Yeah, so it's the way I think about the chain rule or the quotient rule is bottom times derivative of the top minus top times the derivative of the bottom is the way I say it in my head, because I don't want to link it to F's and G's, because if the problem has an F and a G in it, or like we've named the thing like the top is G and the bottom is F, and like intentionally trying to confuse me, I'm just saying top and bottom when I write the formula. Just like when I do the chain rule, I don't think about F's and G's, I think about inner, outer, because it just, like that to me, I get less turned around with like, if the labeling is weird. Okay, so if I'm going to simplify this down here because this is kind of a nightmare without doing that. So I have 2t plus 1 minus 2t plus 4, which is great because that all goes away. We'll distribute the negative. Yep, that's good though. If you're not sure, ask if you think I'm making a mistake, because sometimes I do, right? It does happen. Sometimes they're not even on purpose mistakes. Most of the time they're not on purpose. All right, let's put things together now. So I have the derivative of the outside and then the inside. and then times okay. Now, if it's me and I'm writing the textbook answer in the back, this is not how I'm going to leave it.
Like, if you make an effort to know.
Yes.
Leave it like this.
Yes.
So
Yes.
our homework, can we leave it?
Yes. But when you check in the back of the book,
It's good.
I would be shocked if they didn't write it this way.
And then you said multiple choice, is it gonna be simplified or?
They will definitely simplify it in the multiple choice,
Okay.
which is okay because all you have to do is look at this and be like, okay, can't be this one, can't be that one, right? And do we see how I got to this answer?
Yeah.
9 times 5 is the 45. The exponent 8 for the numerators, because the numerator is to the 8th power. The denominator, 2t plus 1, I have 2 of them here, 8 of them here. That's where the 10 comes from. Which is how they would write. I'd be shocked if this is a multiple choice question if they did not write it in that form. Because that's part of what they're doing in the multiple choice section. By not requiring simplification in the free response, they're going to check for it in the multiple choice section by giving you a problem like this and like giving you a simplified answer. So you can at least minimally look at your answer and go, okay, it has to be C. Can't be A, can't be B, can't be D, has to be C or something. Even if you don't do the simplification yourself, you should at least be able to see like, can't be this one, can't be that one. Where it gets difficult is when, if there's a bunch of trig involved also, because you may end up with like a quotient rule and they'll like multiply everything through by like sine over sine and like turn them into secants and there wasn't even a secant in the problem kind of thing. It's like, oh my God, where is this coming from? Those are the hard ones in terms of the simplifying, is running into the trig stuff. Okay. Let's take a look at this next one. What do we see here? Absolutely, yeah. I see a product and 2 chains, right?
How do you know?
Well, again, if I look at, there is no like one outer function here, right? This piece has an outer function and that piece has an outer function, but there's multiplication in between them. So the product is going to come first because there's nothing around the entire problem, right? I see 2 distinct pieces that are chained, but they're distinct, right? As opposed to the previous problem where to the 9th was around the entire thing. So the chain is coming first there, and the quotient is inside of it. So if I think about this as like f of x, and this is g of x, I know that y is going to be f times g prime of x plus g times f prime of x, right? But to do each one of these requires a chain. Everybody's okay there? Let's see if we can do that chain rule in our head without writing everything down. Eventually, this is where you'd want to get to.
5, 2x plus 1.
So you're going to have 4.
Oh, that one.
And then the inside. And the new exponent should be 3, because it's just a power rule, right? And then times the derivative of the inside. Okay. Now, if you can't do that right now, that's okay, right? That's totally fine. Eventually, you're going to do this enough to where it's going to feel comfortable doing that. So we're just stretching ourselves a little bit now, maybe a little bit before we're ready. But you can see where, like, if I try to just like everything is F and G and then K and H, I'm going to run through like an entire alphabet in a problem and gets a little overwhelming. Sometimes it's even easier to just be like, write down what I've done and then do the chain. If the chain rules are easy chains, like they're just power rule chain rules like we're doing here, it can be easier to just do it in our head. So again, we have our G, and now F prime. Let's try to do that one in our head. So we're doing this derivative in our head. So it should be 5, right? And then the inner to the 4th times the derivative of the inner. All right. Now here's the lousy part. How are they going to simplify this? Here's what we're going to do. If I look at this piece and this piece, I have a greatest common factor of 2x plus 1 to the 4th, correct? If I look at this piece and this piece, I have a greatest common factor of x cubed minus x plus 1 to the 3rd. And then what's going to be left? Well, I have I have one of these. And then I have the 4. And then I have this. Plus, I got one of those. I have the 5 and the 2. So far, so good. Now I just need to multiply these stuff out and combine some like terms. So when I FOIL this out, I'm going to have 6x cubed plus 3x squared minus 2x minus 1, and then we have to multiply everything through by 4 still. Over here, I just multiplied through by 10. That's not so bad. So if I simplify this down, what do I have? I have 34x cubed plus 12x squared minus 18x plus 6. So like my final answer I would write would be that. That would be my suspicion of what it would look like in the back of the book. Now that's a hassle, right? The calculus piece wasn't too bad. The simplification at the end was rough. Do you need to do that for me? No. But if you're checking your work, that's the way it's going to check. Okay? Elena. That's what we did. Yes. Yes. 100%. Because if I look at the original problem, there is no outer function around the entire problem, right? So I have to do the product rule first, and when it comes to doing the derivatives, each of these requires a chain rule. So when I did the F or the G prime and the F prime, those required the chain rules inside of my product. Does that?
Yes.
Okay. Tessa, I saw your hand. Do you have one? Okay. Did I not see your hand? Oh, Pierce, what's up?
So you would just stop at that like long first part, or like the second y prime.
You could stop here if it was
Oh, you can?
not a free response or in your homework even, that's okay. Just keep in mind that like the multiple choice questions I'm going to give you are going to be simplified answers potentially.
Will they be that complex though?
Potentially, yes.
Oh.
Now, again, it's probably one where like you shouldn't have to do all the simplifying to figure out which one it is. You can probably do some like eliminate, like, okay, it can't be any of these, it has to be that one, right? Like I didn't actually do the simplification, but I looked at the other choices enough to eliminate all but one of them, and I'll just go with that because it's a time setting, right? They're not expecting you to do all the simplification, but they are expecting you to be able to look at the answers enough to go, okay, here's my answer. Can't be that one, can't be okay, this is the one it has to simplify to, and just go. You know what I'm saying? All right. Okay, here we have y equals e to the sine x. How are we going to differentiate that? What's my outer?
Yes.
Good, e to the x. And my inner then is sine x, great. So the derivative of e to the x is e to the x. And the derivative of sine x is cosine x. So my derivative should be e to the sine x times cosine x. And you're done. Okay. New derivative rule. This is one you would need to memorize. The derivative of a to the x is a to the x times the natural log of a. Note when a is equal to e, what does that really turn into? E to the x times the natural log of e. And the natural log of e is just 1. That's why we're just getting e to the x as the derivative. Elena, good job. I heard you yell it. You're welcome. So again, that's what we're getting there. All right. Let's see some multiple chain rules. These you need to practice this. Like this is like symbol pushing. Like we need to practice this kind of stuff. Like it's about reps. It's not theoretical.
No, if you look at it, the 15 through 45 is the second portion of that isn't calc that we have to do outside of what we're doing.
Yeah, the black is just the numbers inside of that 15 or
It looks like
1 to 45.
So that is a
That's
lot.
kind of
All right.
black.
Guys, no, you guys
It's not
not
bad. It's not bad.
But like,
It feels
so
the
much.
first half though is like all like a
Okay,
We'll see.
so let's look at this. Let's look at example 8. Let's look at example 8. What do we see?
chain double chain rule.
This is
Triple chain rule.
it's 2.
Oh.
It's 2 linked chain rules though, right? What is the outer function? Sine x. And then the inner then is cosine of, or cosine x of, or sorry, cosine of tan x.
Which is its own chain right there.
which is when we have to do h prime, will require another chain rule. So let's say k of x then is our cosine x, and HHIJK L of x is our inner.
Doing a chain rule is chain. That's what 30
So you see already this is getting a little bit number confusion, right? Like, or letter confusion. It's getting to be a lot to keep track of. So when I look at this, this is the way that I see it in my head. I see outer. Derivative of the outer is cosine. Yes, that's the derivative of tangent. So there's the derivative of the outer, right? Now when I do this, that's the outer. Derivative of cosine is negative sine. And then this is now my last one. Derivative of tangent is secant squared. So that's the way I'm seeing it in my head. I'm not writing any of this intermediate stuff down. Once you get good at it, that's probably where you're going to land, because sorting through what we just did there, like we have like all these things to piece together, right? That f prime is going to be like g prime of h of x times h prime of x, which is g prime of h of x times k prime of L of x times L of x, right? Which is what that boils down to, where like that is our g prime of h, that is our k prime of L, and that is our L prime. Again, I am trying to show you both ways of looking at it. Like, what does it look like when you do these in your head? What does it look like if I'm going to piece these out with a lot of notation? How do I keep track of it? You know, like that's what you're doing. You're doing like one step and then a second step, because to do h prime, you had to do another chain rule, so you needed more letters. Now imagine having, like, instead of 2 of these, you have 3 of these linked together, or 4 of these linked together. Like, the alphabet soup just gets really overwhelming pretty quick, which is, again, like, you know, why we're just, at some point, you want to try to think about just doing these in your head, because it just, in a way, becomes less overwhelming.
Can the chain rule apply to just like about almost everything else we've done, as long as like not like it starts with
Yeah, derivative, a chain rule is just a way of doing a derivative of a composition. So some of the things we've done before, you could think of as compositions, right? Like we've done things like this x cubed minus 1 to the 99 or the 100th. We've done stuff like that where we FOILed it out and then did the derivative of it. We can now just skip the foiling out and just do a chain rule on it. Or if you want, if it's a small exponent like a 2 or a 3 and you would rather just grind it out, you can still do it that way. All right, we have one more example. All right. When we look here, e to the secant of 3 theta. Yeah, that's the outer. So the inner, okay. That's good. So y prime is going to be f prime of g of x times g prime of x, right? What do I have to do g prime, though? That's another chain rule. Yeah. Where your outer is going to be secant x, and your inner is going to be 3 theta. So this is going to be, oops, not g anymore though. It's going to be h prime of k of x times k prime. And sometimes this I would do, like that's okay as you're getting started. That's not too overwhelming looking. Because the g prime of x is that.
Oh.
That's me doing a second chain rule. Oops. And then what's the derivative of secant? I always forget these two, or confuse them anyways. Where is it?
Secant x.
That's it. I couldn't remember if it was the negative or not on that one. All right, where is that? That's down at the bottom. There's that, which is super cool. Okay. What's up?
No, I like this.
You dig this?
I do like this one. It's much shorter than the others.
It's no memorizing, right? It's just like using it.
Yeah.
It's not like it's a rule to memorize. It's like not a formula to memorize. It's just like, this is how you have to do a composition. Yeah, it is. It's lovely. Lovely rule. I still have some more stuff to talk about that isn't covered explicitly well in your textbook with regard to the chain rule. We'll do that at kind of the start next time, and then we'll continue on into implicit differentiation. If we need to spend 2 days there because of that, it's fine. We'll figure it out. But that's the plan. I want to talk about inverse functions and doing the derivative if you have two functions that are inverses in a composition. So maybe we'll just make that a new page. Okay. I think I put the examples in the 3-4 part. Or in the fourth hour section. I need to move that around a little bit then. I was making the homework quiz lists this morning. Yes, sir.
So is this homework due this weekend?
So this weekend, what will be due at this point is going to be 3-3, 3-4, and then depending on what we do next time, if we finish 3-5 on Wednesday, then that'll be part of this weekend's set. If it drags into 2 days, then it wouldn't be. Or if you guys just object and are like, it's just too much homework in 1 week, we can push it into next week, where I think the problem set's on 6 and 7 are quite a bit shorter. But sections 4 and 5, I think, are the two hard ones, the two hardest ones in this test. Okay? Just because section 4, we start getting a lot of symbol pushing going, right? You can really get some complicated derivatives.
Chapter 4 or like 3.4?
3.4 and 3.5, I think, are the two hard sections for this test. Two hardest sections. Okay.
So,
Yeah.
why did it get into trouble?
Well, the bad part, Elaine, is that like now with the chain rule, I can take all these derivative rule problems and just like mix them all together, and they can all just become in one. I can have one problem where you have to use the trig rules and the exponential and the power rules and the product and the quotient and the chain. Like you can get one horrible problem that has like everything in it.
I leave the symbols.
Sure thing.